Before we begin, take a moment to get comfortable. If you enjoy slow, calming journeys through space, quiet science, and ideas that gently stretch your sense of reality, consider subscribing. New long-form space documentaries are released here regularly, designed for sleep, focus, and deep curiosity. Tonight, we're not chasing answers, we're sitting with questions. Despite centuries of observation, powerful telescopes, and equations that describe the universe with astonishing precision, there are still things in space that refuse to fully make sense, not because we haven't tried hard enough, but because the universe is deeper, stranger, and more subtle than our current understanding allows. In this slow and peaceful documentary, we'll explore 101 facts about space that scientists still can't fully explain. These aren't science fiction ideas or wild speculation. Each fact comes from real observations, measured, tested, and confirmed, yet still surrounded by uncertainty, debate, or missing pieces. Some of these mysteries are vast, stretching across billions of light years. Others are surprisingly close, hidden in the behavior of stars, gravity, time, and even empty space itself. Together, they remind us that modern science is not a finished story. It's a conversation still unfolding. There's no rush here. Each fact is presented gently, one at a time, allowing your mind to wander without pressure. You don't need to remember everything. You don't need to solve anything. Just listen, relax, and let the unknown be what it is. As the universe slowly reveals its unanswered questions, you may find that uncertainty itself can be calming. Because not knowing everything is not a failure of science. It's what keeps discovery alive. So let's begin. One quiet mystery at a time. When we look at the universe today, it's easy to believe that science has explained most of it. We can measure the age of the cosmos, map galaxies billions of light years away, and detect ripples in space-time itself. And yet, beneath all that progress, there remains a quiet truth. Much of what we observe still resists complete explanation. This journey begins not with answers, but with observations, facts confirmed by data, instruments, and repeated measurements, that scientists still cannot fully explain. These are not gaps caused by ignorance or lack of effort. They exist because the universe behaves in ways that stretch the limits of our current understanding. Let's start with one of the most unsettling realizations in modern science. Fact 1. Most of the universe is made of something we can't see or directly detect. Roughly 95% of the universe is composed of dark matter and dark energy. Together they dominate the cosmos. Yet neither emits light, absorbs light, nor interacts with normal matter in any direct, familiar way. We know they exist only because of how they influence gravity and cosmic expansion. What they truly are remains unknown. Fact 2. Dark matter behaves like matter, but isn't made of known particles. Dark matter forms massive halos around galaxies, shaping their structure and motion. Without it, galaxies would fly apart. But despite decades of experiments deep underground and in space, no confirmed dark matter particle has ever been detected. Fact 3. Dark energy is causing the universe to expand faster over time. Instead of slowing down under gravity, the expansion of the universe is accelerating. This discovery shocked scientists in the late 1990s. Dark energy appears to be pushing space itself apart, yet its nature is completely mysterious. We don't know where it comes from, why it exists, or whether it will change in the future. Fact 4. Empty space is not truly empty. Even the darkest regions of space are filled with quantum fluctuations, tiny, spontaneous bursts of energy that appear and disappear. These fluctuations have measurable effects, yet their deeper meaning challenges our understanding of what nothing actually is. Fact 5. The universe has a preferred temperature. Every direction we look, space glows faintly at about 2.7 degrees above absolute zero. This cosmic microwave background is leftover radiation from the early universe. It's remarkably uniform, but not perfectly so, and those tiny irregularities seeded all galaxies. Why the universe started with such precise conditions remains unexplained. Fact 6. The universe appears flat. On the largest scales, space follows the geometry of flatness, balanced precisely between open and closed shapes. This balance is extraordinarily delicate. Even slight deviations in the early universe would have produced a radically different cosmos. Why the universe landed so perfectly on this edge is unknown. Fact 7. Time behaves differently depending on motion and gravity. Time slows down near massive objects and at high speeds. This isn't theory, it's measured reality. Yet why time exists at all, or why it flows in one direction instead of another, remains deeply mysterious. Fact 8. The arrow of time points forward, but physics allows time symmetry. Most fundamental laws of physics work equally well forward or backward in time. And yet, we experience time moving only one way. Why the universe has a preferred temporal direction is still unanswered. Fact 9. The universe began in an extremely low entropy state. At the moment of the Big Bang, the universe was remarkably ordered. This defies intuition, as explosive beginnings typically increase chaos. Why the universe started so ordered remains one of the deepest puzzles in cosmology. Fact 10. We don't know what triggered the Big Bang. The Big Bang describes expansion, not origin. It explains how space evolved, not why it existed at all. Whether the universe emerged from a quantum event, a prior universe, or something entirely different is still unknown. Fact 11. The observable universe may be only a tiny fraction of reality. We can only see as far as light has travelled since the Big Bang. Beyond that cosmic horizon, space may continue endlessly, or loop back on itself, or connect to regions governed by different physical laws. Fact 12. Inflation may have shaped everything, but remains unproven. Cosmic inflation suggests the universe expanded incredibly fast in its first moments. It explains many observed features, yet direct evidence remains elusive. The mechanism behind inflation is still hypothetical. Fact 13. Some constants of nature appear finely tuned. If fundamental constants were slightly different, stars, atoms, and life would not exist. Whether this fine-tuning is coincidence, necessity, or evidence of deeper laws is unresolved. Fact 14. Gravity does not fit cleanly with quantum mechanics. We have two powerful theories, general relativity and quantum mechanics. Each works beautifully, but not together. Gravity resists quantization, and no unified theory has yet succeeded. Fact 15. Black holes destroy information, or maybe they don't. According to quantum physics, information can never be lost. According to classical black holes, anything crossing the event horizon is erased. Reconciling these views remains one of physics' greatest challenges. Fact 16. Space and time may not be fundamental. Some theories suggest space-time emerges from deeper structures, like quantum entanglement or information networks. If true, space and time are not the universe's foundation, but a consequence. Fact 17. The universe may be filled with unseen dimensions. String theory predicts extra spatial dimensions beyond the three we experience. These dimensions may be curled up at tiny scales, influencing physics invisibly. Fact 18. The vacuum has measurable pressure. The Casimir effect shows that empty space exerts force. This suggests that nothing has physical properties, but why it does and how strong it should be remains unclear. Fact 19. Antimatter behaves almost exactly like matter. Yet the universe is overwhelmingly made of matter. Somewhere early on, matter gained a tiny advantage over antimatter. Why this imbalance exists is unknown. Fact 20. Neutrinos barely interact with anything, but shape the cosmos. Trillions pass through your body every second. They influence cosmic evolution, yet their exact masses and properties remain uncertain. As these facts accumulate, a pattern begins to emerge. The universe is not just vast, it is subtle. Its behavior is shaped by forces we barely understand, entities we cannot see, and principles that feel incomplete. This isn't failure, it's perspective. Every unanswered question represents a boundary, not of ignorance, but of current knowledge. The universe is not obligated to be simple, intuitive, or fully accessible to human reasoning. As we continue, the mysteries will grow deeper. Some will involve galaxies and cosmic voids. Others will unfold at the smallest imaginable scales. Together they form a quiet reminder. Science does not close doors. It reveals how many still remain open, and we are only beginning. As we move deeper into the universe's unanswered facts, the mysteries stop being distant and abstract. They begin to touch the rules that govern everything around us, from the stars overhead to the atoms inside your body. What once felt like cosmic curiosities slowly reveal themselves as fundamental cracks in how we understand reality itself. Some of the most unsettling facts are not about distant galaxies, but about the basic nature of existence. Fact 21. We don't know why the laws of physics are the same everywhere. No matter where we look, billions of light years away, or right here on Earth, the same physical laws apply. Gravity behaves the same, light travels at the same speed, atoms follow the same rules. There is no known reason the universe should be this uniform, yet it is. Fact 22. The speed of light is constant for all observers. Even if you move toward or away from a beam of light, its speed never changes. This defies everyday intuition and forces time and space themselves to adjust instead. Why the universe chose this constant value and why it enforces it so strictly remains unexplained. Fact 23. Space can expand faster than light without breaking physics. While nothing can travel through space faster than light, space itself can stretch faster than light expands across it. This is how distant galaxies recede beyond our observable horizon. The difference between motion in space and motion of space remains deeply unintuitive. Fact 24. There may be regions of the universe forever unreachable, because space expands. Some galaxies are moving away faster than light can ever reach us. Their future light will never arrive. Entire regions of reality may exist forever beyond observation. Fact 25. We don't know if the universe is infinite. Observations suggest vastness beyond comprehension, but infinity itself cannot be measured. The universe could be finite yet unbounded, looping back on itself in ways we cannot detect. Fact 26. The universe has no clear center. No matter where you stand, galaxies appear to recede away from you. This isn't because you are at the center, it's because space itself expands uniformly. A universe without a center challenges every instinct about structure. Fact 27. Galaxies rotate faster than visible matter allows. Stars at the edges of galaxies move too fast to be held together by observable mass alone. Without dark matter, galaxies should tear themselves apart. Why dark matter arranges itself the way it does is unknown. Fact 28. Some galaxies formed surprisingly early. We observe massive, mature galaxies existing when the universe was very young. According to current models, they shouldn't have had enough time to form. Something in our understanding of early structure formation may be incomplete. Fact 29. Supermassive black holes appeared too quickly. Black holes millions or billions of times the Sun's mass exist only a few 100 million years after the Big Bang. How they grew so large so fast remains unexplained. Fact 30. Black holes warp time to an extreme degree. Near a black hole, time slows dramatically. To a distant observer, infalling matter appears frozen at the event horizon. Yet the falling object, time, continues normally. Both perspectives are correct. Fact 31. We don't know what happens inside a black hole. The laws of physics break down beyond the event horizon. Space and time swap roles. Our equations no longer produce meaningful answers. Fact 32. Singularities may not actually exist. Mathematical singularities indicate incomplete theories, not necessarily physical objects. A future theory of quantum gravity may remove singularities entirely. Fact 33. Hawking radiation suggests black holes can evaporate. Black holes slowly lose mass over immense timescales. This raises questions about what happens to the information stored inside them. Fact 34. Information loss may violate fundamental principles. If information truly disappears, quantum mechanics may be incomplete. If it doesn't, then black holes must encode information in ways we don't yet understand. Fact 35. Spacetime may be granular at the smallest scales. Some theories suggest space and time are not smooth, but composed of tiny, discrete units. If true, reality is pixelated at scales far smaller than atoms. Fact 36. The Planck length sets a limit to measurement. Below a certain scale, distances lose meaning. Our current understanding cannot describe what exists beyond this boundary. Fact 37. Quantum entanglement connects particles instantly. Entangled particles affect each other regardless of distance. This connection appears to transcend space, yet does not transmit information faster than light. How this works remains mysterious. Fact 38. Reality may be fundamentally non-local. Entanglement suggests that distant objects are not fully independent. The universe may be deeply interconnected beneath the surface. Fact 39. Observation changes outcomes. In quantum experiments, measuring a system alters its behavior. Whether this reflects limits of knowledge or deeper truths about reality remains debated. Fact 40. Probability is built into the universe. At fundamental levels, outcomes are not deterministic. Only probabilities exist. Why nature behaves probabilistically rather than predictably is unknown. Fact 41. Virtual particles briefly exist and influence reality. Particles can appear from empty space and vanish instantly. Their effects can be measured despite their fleeting existence. Fact 42. Energy conservation can be locally violated in quantum systems. For extremely short times, energy appears to fluctuate. This challenges classical ideas of strict conservation. Fact 43. Time may not be fundamental. Some theories suggest time emerges from deeper, timeless laws. If true, time as we experience it is an illusion arising from change. Fact 44. The present moment is hard to define physically. Physics does not clearly define now. Different observers disagree on what events are simultaneous. Fact 45. The universe may contain multiple timelines. Certain interpretations of quantum mechanics allow branching realities. Whether these branches are real or mathematical remains unknown. Fact 46. Consciousness is not explained by physics. Despite advances in neuroscience, subjective experience remains unexplained by physical laws. Fact 47. Life appeared quickly on Earth. As soon as conditions allowed, life emerged. Whether this is common or rare remains uncertain. Fact 48. We don't know how life began. The transition from chemistry to biology has never been fully explained. Fact 49. The universe appears strangely hospitable to complexity. Stars, planets, chemistry, and stable environments exist across vast timescales. Why complexity is even possible is still unclear. Fact 50. The universe may be stranger than any model we currently imagine. Every generation of science uncovers deeper layers of mystery. There is no reason to believe we are near the end of that process. At this point, it becomes clear that the universe is not merely a collection of objects. It is a system governed by principles that remain only partially revealed. Each discovery answers a question while opening several more, and perhaps that is the most honest truth science offers, not certainty, but humility. The universe invites us to explore, not because it promises closure, but because it continues to surprise us, and there is still so much more it hasn't yet explained. As these facts accumulate, something subtle begins to change. The universe no longer feels like a puzzle waiting to be solved, but like a landscape whose depth increases the longer you stare into it. Each unanswered question doesn't stand alone. They begin to connect, overlap, and quietly suggest that reality may be far less solid, far less complete than it appears. We now move into mysteries that sit at the edge of observation, places where evidence exists, but interpretation becomes fragile. Fact 51. We don't know what most of the universe looks like right now. Because light takes time to travel, everything we see is a snapshot of the past. Distant galaxies appear as they were billions of years ago. The present state of most of the universe is permanently hidden from us. Fact 52. Some regions of space may already be gone forever. Cosmic expansion means that parts of the universe have crossed beyond our ability to ever interact with them again. They still exist, but are causally disconnected from us. Fact 53. The universe could be much larger than what we observe. The observable universe is limited by time, not by size. Beyond the cosmic horizon, space may continue endlessly, or curve back on itself in ways we cannot detect. Fact 54. Cosmic voids make up most of the universe's volume. Vast regions of near emptiness stretch between galaxies. These voids are not simply gaps. They influence galaxy motion and cosmic structure, yet remain poorly understood. Fact 55. The largest structures in the universe challenge formation models. Gigantic walls and filaments of galaxies span distances that seem too large to have formed naturally within the universe's age. Their existence strains current cosmological theories. Fact 56. The universe may have preferred directions. Certain large-scale alignments appear in cosmic background radiation. Whether these are statistical coincidences or hints of deeper structure is still debated. Fact 57. Space itself may have a minimum unit of volume. Some theories suggest space cannot be divided infinitely. Below a certain scale, the concept of distance may lose meaning entirely. Fact 58. We don't know why there are exactly 3 dimensions of space. Physics allows for more dimensions, yet we experience only 3. Why these dimensions are extended while others remain hidden is unknown. Fact 59. Time behaves strangely near extreme gravity. Near massive objects, time slows dramatically. In some models, time may even stop entirely at certain boundaries. Fact 60. The universe has a maximum speed, but no maximum size. Nothing can move faster than light, yet space itself has no known upper limit in extent. Fact 61. Some particles appear from nowhere and vanish instantly. Quantum fields allow particles to briefly exist without violating conservation laws. These fluctuations affect measurable phenomena. Fact 62. The vacuum has energy, but its value makes no sense. Theoretical predictions of vacuum energy differ wildly from observations. This discrepancy is one of the largest unsolved problems in physics. Fact 63. Gravity is incredibly weak compared to other forces. Despite shaping galaxies and cosmic structure, gravity is vastly weaker than the electromagnetism or nuclear forces. Why this imbalance exists is unknown. Fact 64. The universe allows long-term stability against expectation. Stars burn steadily for billions of years, planets maintain orbits, and chemistry persists. Such stability seems unlikely in a chaotic universe, yet it exists. Fact 65. We don't know how common Earth-like planets truly are. Thousands of exoplanets have been discovered, but Earth analogues remain rare and difficult to confirm. Fact 66. Planetary systems come in unexpected configurations. Many exoplanet systems look nothing like our own. Hot Jupiters, tilted orbits, and compact systems challenge formation models. Fact 67. Some planets shouldn't exist according to theory. Observed worlds defy expectations of temperature, composition, and orbital stability. Fact 68. Stars can migrate across galaxies. Over billions of years, stars drift from their birthplaces. This migration complicates efforts to trace galactic history. Fact 69. We don't fully understand stellar death. Supernova mechanisms remain partly unexplained, especially for stars at the edge of mass limits. Fact 70. Neutron stars compress matter beyond comprehension. Inside neutron stars, matter exists in states not reproducible on Earth. What exactly lies inside them remains unknown. Fact 71. Magnetic fields shape cosmic evolution. Galactic and interstellar magnetic fields influence star formation, yet their origins are unclear. Fact 72. Cosmic rays arrive with extreme energies. Some particles reach Earth with energies beyond known astrophysical processes. Their sources remain mysterious. Fact 73. The universe may recycle matter endlessly. Stars form, die, and seed future generations. Yet the long-term fate of this cycle is uncertain. Fact 74. We don't know when star formation will end. As gas supplies diminish, star birth will slow. When the last star forms is still unknown. Fact 75. The universe has no clear endpoint in time. Whether the universe will end, fade, collapse, or continue forever remains an open question. By this point, the mysteries are no longer isolated anomalies. They form a pattern, not of confusion, but of depth. The universe reveals itself as a system layered with limits, horizons, and thresholds, beyond which understanding becomes provisional. This does not mean knowledge is failing. It means reality is not obligated to be transparent. Science moves forward not by erasing mystery, but by reshaping it, turning unknowns into sharper questions. And as those questions deepen, the universe feels less like a machine and more like a process still unfolding. The more we learn, the clearer it becomes that certainty was never the destination. Curiosity was, and the universe, vast and patient, continues to offer more than we are ready to fully explain. As the picture widens even further, the mysteries of the universe begin to lean forward in time. They are no longer only about what exists now, or what existed in the past, but about what has not yet happened, and what may never happen at all. These unanswered facts remind us that the universe is not just unfinished in our understanding, but unfinished in its story. Some of the most profound unknowns are not hidden in distant galaxies, but embedded in the future behavior of reality itself. Fact 76. We don't know the ultimate fate of the universe. The universe could expand forever, slowly fading into darkness. It could tear itself apart in a dramatic rip. It could collapse back inward, or it could settle into a quiet, cold equilibrium. Each possibility is supported by current physics, and none can yet be ruled out. Fact 77. Dark energy may not be constant. The force driving cosmic expansion could weaken, strengthen, or change behavior entirely over time. If it changes, the future of everything changes with it. Fact 78. The universe may already be entering a quieter era. Star formation peaked billions of years ago and has been declining since. The universe is slowly becoming less active, though the process is so gradual we barely notice. Fact 79. We don't know when the last star will be born. At some point, the raw materials for star formation will run out. When that happens, the night sky will slowly go dark forever. Fact 80. Black holes may outlive everything else. After stars fade and galaxies dissolve, black holes could remain for unimaginable lengths of time. Their eventual evaporation through Hawking radiation is predicted, but never observed. Fact 81. We don't know what happens after the last black hole disappears. When the final black hole evaporates, the universe may enter a state where nothing complex can ever form again. What that state truly looks like is unknown. Fact 82. Time may lose meaning in the far future. Without change, structure, or observers, the concept of time may become meaningless. Whether time can exist without events is an open question. Fact 83. Entropy may not be the final word. While entropy tends to increase, some theories suggest rare fluctuations could create new pockets of order. Whether this ever happens on cosmic scales is unknown. Fact 84. The universe may experience rare, spontaneous events. Quantum fluctuations could, in principle, produce unexpected structures even in a near-dead universe. These events would be unimaginably rare, but not forbidden. Fact 85. We don't know if the universe can reset itself. Some theories suggest cycles of universes where one cosmos gives rise to another. Whether our universe is unique or one of many remains unanswered. Fact 86. The laws of physics may evolve. What we consider fixed laws might change slowly over cosmic timescales. There is no proof they are eternal. Fact 87. We don't know if reality has the smallest meaningful scale of time. Below certain limits, time itself may fragment or lose continuity. What lies beneath that boundary is unknown. Fact 88. Space may not remain smooth forever. Extreme expansion could stretch space-time until familiar geometry no longer applies. Fact 89. Information may be preserved forever or not. Physics insists information cannot be destroyed, yet extreme cosmic processes challenge this assumption. Fact 90. The universe may never repeat itself. Even infinite time does not guarantee repetition. The number of possible states may be far larger than intuition suggests. Fact 91. We don't know if complexity is temporary or inevitable. Life, intelligence, and structure may be rare accidents or natural outcomes wherever conditions allow. Fact 92. Conscious observers may influence what questions can be asked. Some interpretations suggest observation itself shapes reality at deep levels. Whether this applies beyond experiments is unknown. Fact 93. The universe may not care whether it is observed. Reality continues regardless of awareness. Meaning may be something added by observers, not something built in. Fact 94. The universe does not offer final answers. Every explanation opens new questions. There is no known endpoint to inquiry. Fact 95. We may never fully understand the universe. Limits of observation, lifespan, and cognition may place permanent boundaries on knowledge. Fact 96. Not knowing is part of the scientific process. Uncertainty is not a flaw. It is a feature that drives discovery. Fact 97. Mystery does not mean ignorance. Many unknowns are sharply defined. We know precisely what we don't know. Fact 98. The universe is larger than any single framework. No single theory currently explains everything. Reality may require multiple overlapping perspectives. Fact 99. Our current models are provisional. Every generation revises what it thought was complete. Fact 100. The universe continues regardless of understanding. Stars form and die. Space expands. Time moves forward. None of it waits for explanation. Fact 101. The greatest mystery may be that the universe is knowable at all, that patterns exist, that laws hold, and that understanding is even possible remains unexplained. When these facts settle together, they form a quiet conclusion. Not an answer, but a perspective. The universe is not a puzzle to be solved once and closed. It is a process that unfolds, revealing just enough to invite curiosity and withholding enough to remain endlessly deep. There is comfort in this. Not everything needs resolution. Not every mystery needs an ending. Sometimes, the most honest response to the universe is simply to observe, to wonder, and to accept that understanding is always a work in progress, moving slowly, patiently, through a reality far larger than we can ever fully explain. As everything begins to settle, the unanswered questions don't fade away. Instead, they soften. They stop demanding resolution and start offering something quieter: perspective. When we step back far enough, the unknown stops feeling like a gap in knowledge and starts feeling like a feature of reality itself. Many of the things we cannot explain are not errors in measurement or missing data points. They exist because the universe operates on scales that stretch beyond intuition, language, and even imagination. Our minds evolved to navigate forests, seasons, and survival, not cosmic time, relativistic speeds, or space-time curvature. One of the strangest realizations is that explanation itself may have limits. There are questions that can be framed mathematically, but never visualized. Others can be described but never tested. Some may be true, false, or meaningless depending on the framework used to ask them. This does not mean science is weak. It means reality is deeper than any single approach to understanding it. Consider how often our strongest theories work perfectly and still leave something unexplained. Gravity predicts planetary motion with extraordinary precision, yet its fundamental nature remains mysterious. Quantum mechanics predicts outcomes flawlessly, yet cannot tell us why those outcomes occur. Cosmology traces the universe back to its earliest moments, yet cannot say what came before. These are not small cracks. They are deep seams running through our best understanding of reality, and yet the universe continues to behave consistently. Stars burn, galaxies rotate, time flows, space expands. Reality does not collapse because we don't understand it fully. It doesn't hesitate. It doesn't simplify itself for our benefit. It simply continues, indifferent to comprehension. This raises a subtle and often uncomfortable idea. Understanding may not be required for existence. The universe does not depend on being explained. Meaning, interpretation, and narrative are human additions. Useful, beautiful, and powerful, but not fundamental. The cosmos functioned for billions of years before the first mind asked a question, and it will continue long after questions stop being asked. In that sense, mystery is not a problem waiting for a solution. It is the natural state of a universe viewed from the inside. Another quiet truth emerges when we reflect on these facts. Uncertainty does not reduce wonder, it increases it. If everything were fully explained, predictable, and closed, curiosity would end. Discovery would become repetition. The universe would feel smaller, not larger. The unknown keeps the cosmos open, dynamic, and alive to exploration. Every unanswered question becomes a doorway rather than a wall. Even concepts that once seemed unreachable slowly come into focus over time. Ideas like curved spacetime, expanding space, and quantum fields were once unimaginable. What feels impossible now may simply be waiting for a new way of thinking. At the same time, some mysteries may never yield, not because we failed, but because the universe does not promise closure. There is no final chapter where everything resolves neatly. No ultimate explanation that collapses all questions into one answer. Reality may simply be layered, with each layer revealing deeper structures that remain partially hidden. And that is not a flaw. It is what allows science to exist as a living process rather than a finished product. As you listen to these facts, it becomes clear that science is not a collection of answers. It is a method of remaining curious without certainty. It teaches us how to ask better questions, how to test ideas carefully, and how to accept that not knowing is not failure. Some of the most important discoveries in history came from admitting ignorance. Dark matter was proposed because galaxies didn't behave as expected. Dark energy emerged because expansion didn't slow down. Quantum mechanics was born from results that made no sense under classical assumptions. Every mystery we've discussed today follows that same pattern: observation first, explanation later, or never. And sometimes, never is acceptable. There is a calm that comes with realizing that the universe does not owe us clarity. That existence is not a riddle designed for human minds to solve. That understanding is something we grow into gradually, piece by piece, without ever reaching a final destination. In that calm, curiosity becomes gentle rather than urgent. You don't need to resolve these mysteries tonight. You don't need to remember every fact. You don't need to carry the weight of the unknown. You can simply let these ideas pass through your mind the way starlight passes through space, quietly, steadily, without asking to be owned. The universe remains vast, complex and unfinished, and so does our understanding of it. That shared incompleteness is not something to fear. It is something we share with the cosmos itself, because the universe is not a static object waiting to be defined. It is a process, and we are small, temporary participants within it, observers during a brief window where questions are possible, curiosity exists, and wonder still has room to breathe. And that, perhaps, is one of the most beautiful facts of all. As the ideas settle even deeper, another layer quietly reveals itself, not about what the universe is made of or how it behaves, but about our relationship to it. Many of the mysteries that remain unresolved are not just scientific gaps. They sit at the boundary between observation, interpretation, and perspective. One of the most unsettling realizations is that the universe does not scale to human intuition. We instinctively think in beginnings and endings, causes and effects, objects and distances, but at cosmic scales, these concepts blur. Time stretches until cause and consequence separate by billions of years. Distances grow so large that simultaneity becomes meaningless. Objects exist not as solid things, but as probability distributions, fields, and interactions. Even the idea of now becomes fragile. When you look at the night sky, you are not seeing a single moment. You are seeing a layered archive. Some stars no longer exist. Some galaxies have changed beyond recognition. The present you experience on Earth is not the present of the universe at large. There is no universal clock keeping everything aligned. This raises a quiet, profound question. Does the universe even have a present? Physics allows many interpretations, and none are fully settled. Some suggest the present is an illusion created by consciousness. Others argue that all moments exist equally, laid out like pages in a book. If that is true, then the universe is not unfolding. It already exists, complete with past and future equally real, and yet we experience time flowing. That gap between experience and theory remains unexplained. Another unresolved mystery lies in why the universe is comprehensible at all. The laws of physics are not arbitrary chaos. They follow elegant patterns. Equations written by human minds describe galaxies, particles, and forces with astonishing accuracy. Why reality is governed by mathematics, and why mathematics works so well, has no clear answer. The universe did not have to be understandable. It did not have to allow prediction. It did not have to obey consistent laws across vast distances and timescales. But it does, and no one knows why. This leads to another unsettling possibility. We may be seeing only a thin slice of reality. Our senses evolve to detect survival-relevant signals. Our instruments extend those senses, but they are still limited. There may be entire aspects of reality that never interact strongly with matter, energy, or space-time in ways we can measure. Dark matter and dark energy already suggest this. They dominate the universe, yet remain invisible except through indirect effects. If two unknown components already outweigh everything we can see, there is no guarantee the list ends there. Reality may be layered, with most of it permanently inaccessible. Even the idea of observation itself is not fully understood. In quantum mechanics, observation plays a strange role. Measurement appears to affect outcomes. Whether this reflects a fundamental property of reality, or simply a limitation of interpretation, is still debated. Some models suggest the universe constantly splits into multiple outcomes. Others suggest hidden variables we cannot detect. None of these interpretations have been proven. They coexist, unresolved. This means that at the deepest levels, physics does not tell a single story. It offers multiple narratives that all fit the data, for now. And that is deeply unusual for a science built on precision. Another lingering question is whether the universe is fine-tuned by necessity or coincidence. The constants of nature appear delicately balanced. Small changes would prevent stars, chemistry, or structure from forming. Some see this as evidence of deeper laws we do not yet understand. Others invoke multiple universes, where many variations exist and we simply inhabit one that allows observers. Both explanations remain speculative. We do not know whether the universe had to be this way, or simply happened to be. As these uncertainties accumulate, a subtle shift occurs. The universe stops feeling like a machine with missing parts and starts feeling like a process without a final explanation. Not because knowledge is impossible, but because explanation itself may be contextual rather than absolute. Every theory explains certain phenomena while leaving others untouched. Every framework works within boundaries. Beyond those boundaries, new rules may apply. This suggests that understanding is not about reaching a final truth, but about mapping regions of reliability, knowing where our explanations work and where they fade. In that sense, mystery becomes a boundary marker rather than a failure. The unknown outlines the shape of what we know, and as science advances, those boundaries shift, but they never disappear entirely. Perhaps the most humbling realization is that the universe does not need to be fully understood to be meaningful. Meaning is something minds create. It arises from pattern, memory, comparison, and experience. The universe provides the stage, but meaning is not embedded in the script. And yet, meaning still exists, temporarily, locally, and subjectively. Stars do not care that they burn. Galaxies do not know they rotate. Space does not notice it expands. But within this indifferent framework, complexity emerges that can reflect, question, and wonder. That emergence itself remains unexplained. We do not fully understand how consciousness arises from matter. We do not know whether it is inevitable or accidental. We do not know whether it exists elsewhere, or whether it is rare beyond measure. And yet, here it is, asking questions about a universe that does not answer back. This asymmetry is striking. The universe expresses itself through laws and patterns. Consciousness responds with curiosity and interpretation. One does not require the other, yet they coexist briefly. That coexistence may be one of the rarest phenomena of all. As the universe continues its slow evolution, complexity will eventually fade. Stars will stop forming. Structures will dissolve. The conditions that allow questioning may vanish entirely, and still, the universe will remain. Not empty, not silent, just uninterpreted. In that future, the mysteries we discuss today will not be resolved. They will simply no longer be asked. Which raises one final quiet question. Is understanding the universe about solving it, or about witnessing it while we can? There may never be a final explanation that closes every gap. There may never be a moment when mystery disappears. But perhaps that was never the goal. Perhaps the role of knowledge is not to eliminate uncertainty, but to deepen our relationship with it, to move carefully through what can be known while respecting what cannot, to accept that some questions exist not to be answered, but to remind us of scale, humility, and perspective. The universe is vast, old, and patient. We are brief, curious, and temporary. And in that brief overlap, mystery is not a flaw in understanding. It is the space where understanding lives. As attention drifts even farther outward, another quiet realization begins to surface. The universe is not only mysterious because of what it contains, but because of how it refuses to center anything at all. There is no preferred location, no favored moment, no privileged observer. Wherever you stand, the universe looks roughly the same in every direction, governed by the same rules, unfolding with the same indifference. This principle seems simple, yet it carries profound consequences. It means there is no cosmic here, no universal now, no central stage where reality unfolds more meaningfully than anywhere else. Every point in space is equally ordinary. Every moment in time is equally temporary. And yet, from within this uniformity, complexity arises. One unresolved question is why the universe allows local pockets of order at all. Left to itself, entropy increases. Systems tend toward disorder. Energy spreads out. Differences fade. And yet, for billions of years, stars have burned, planets have formed, chemistry has persisted, and life has emerged. This balance between decay and structure is not fully understood. Gravity gathers matter even as expansion pulls it apart. Nuclear forces bind atoms even as heat tries to scatter them. These opposing tendencies coexist in a fragile equilibrium that should not last. And yet it does, long enough for complexity to bloom. Why this window exists remains unclear. Another mystery lies in the deep connection between seemingly unrelated forces. Electricity and magnetism were once thought separate until unified. Space and time were once independent until revealed as inseparable. Matter and energy were once distinct until shown to be interchangeable. Each unification solved problems and revealed deeper ones. It raises the possibility that forces we currently treat as separate are merely different expressions of something more fundamental. A deeper framework may exist, but we do not yet know how to describe it, let alone test it. Even space-time itself may not be fundamental. Some theories suggest space and time emerge from more basic relationships, like temperature emerging from molecular motion. If true, then asking what exists before time or outside space may be as meaningless as asking what lies north of the North Pole. But this remains speculative. We do not know what reality looks like without space-time. Another unresolved issue is why the universe began in such a low entropy state. At the moment of its earliest description, the universe was extraordinarily ordered. This initial condition set the arrow of time and allowed everything that followed. Why the universe began this way, rather than already disordered, is unknown. Some theories attempt to explain it, others simply accept it as a boundary condition, but no explanation has achieved consensus. Without that answer, the origin of time's direction remains incomplete. There is also the mystery of why the laws of physics appear consistent everywhere. Light behaves the same in distant galaxies as it does near Earth. Atoms form the same way billions of light years away. Constants appear unchanged across cosmic history. This uniformity is not guaranteed, it simply exists. Whether it is a consequence of deeper symmetry, cosmic inflation, or something else entirely remains unresolved. Another quiet puzzle emerges when we consider how little of the universe is actually interactive. Most of space is empty. Most matter never touches anything else. Most events never influence distant regions. The universe is vast, but interaction is sparse. And yet, small interactions have enormous consequences. A slight imbalance in the early universe led to all existing matter. Tiny fluctuations grew into galaxies. Subtle quantum effects shaped macroscopic reality. Small differences amplified over time into structure, complexity, and diversity. Why such amplification occurs, and why it occurred so effectively in this universe, remains only partially understood. Then there is the question of scale. At very large scales, the universe appears smooth and uniform. At smaller scales, it becomes chaotic, clustered, and detailed. At even smaller scales, quantum uncertainty dominates. The rules change with scale, and no single framework seamlessly bridges them all. We can describe each regime well, but not together. A complete description of reality must unify the very large and the very small, the smooth and the probabilistic. That unification remains one of science's greatest open challenges. Another unresolved mystery concerns causality itself. Cause and effect seem fundamental, yet at relativistic and quantum scales, causality becomes flexible. Events can appear simultaneous for one observer and sequential for another. Quantum correlations exist without clear causal paths. Whether causality is fundamental or emergent is still debated. If it emerges, then our deepest intuitions about explanation may not apply at all scales. Even probability behaves strangely in the universe. Some outcomes are predictable only statistically. Others appear truly random. Whether randomness is fundamental or simply reflects hidden structure remains unknown. If randomness is fundamental, then uncertainty is woven into reality itself. If not, then unseen order lies beneath apparent chaos. We do not yet know which is true. As these ideas accumulate, the universe begins to feel less like a thing and more like a process that resists being pinned down. Every attempt to describe it reveals structure, and then reveals limits to that description. This resistance is not antagonistic, it is simply indifferent. The universe does not simplify itself to accommodate understanding. It allows partial understanding and leaves the rest untouched. And yet, within those limits, something remarkable happens. Curiosity persists. Despite uncertainty, despite incomplete answers, despite boundaries that may never be crossed, minds continue to ask questions. The unknown does not discourage inquiry. It fuels it. This suggests that wonder is not dependent on resolution. Wonder thrives precisely where explanation ends. The night sky does not lose its power because we understand stars. It gains depth. Mystery does not vanish when knowledge increases. It transforms. Each answer opens a deeper question. Each discovery reveals a larger context. And the universe, vast and patient, accommodates this endlessly. Perhaps the deepest mystery is not any single unanswered question, but the fact that the universe produces beings capable of noticing mystery at all. That capacity is temporary. It arises briefly in cosmic history. It will not last forever. But while it exists, it allows the universe to be seen, questioned, and contemplated, not from above or outside, but from within. That internal perspective is fragile, limited, and incomplete, and yet it is real. In the end, the universe does not demand that we solve it. It only offers itself, complex, unfinished, and quietly open to curiosity. And as long as questions remain, the universe remains more than a set of answers. it remains a place where not knowing is not a failure, but an invitation to look a little longer, think a little deeper, and accept that some truths reveal themselves slowly, if at all. As the sense of scale continues to stretch, another quiet shift takes place. The universe begins to feel less like a collection of objects and more like a web of relationships, connections that exist not because things are close, but because they are linked through laws, probabilities, and shared origins. Many of the remaining mysteries live inside these relationships, not in any single place. One of the most persistent unknowns is how deeply connected everything truly is. At first glance, the universe appears fragmented. Galaxies drift apart. Stars are separated by vast distances. Most of space is empty, and yet, beneath that separation, everything participates in the same underlying framework. The same constants govern distant galaxies and local atoms. The same quantum rules apply everywhere. The same expansion stretches space uniformly. This unity exists without communication. Nothing needs to travel between regions for them to behave consistently. The rules are already there, everywhere, all at once. Why that is the case remains unexplained. Another unresolved question is why symmetry plays such a powerful role in reality. Many of the laws of physics arise from symmetries, balances that remain unchanged under transformation. Rotate space, reverse time, shift position, and the equations still hold. These symmetries are not imposed, they appear built into reality itself. Yet symmetry is not perfect. Small violations exist. Matter behaves slightly differently than antimatter. Certain processes prefer one direction in time. These tiny asymmetries shaped the entire universe. Without them, nothing complex would exist. Why symmetry exists, and why it breaks just enough, is still unknown. The universe also raises questions about boundaries that are not physical walls. Cosmic horizons limit what we can ever observe. Event horizons block information permanently. Quantum limits restrict precision. These are not barriers made of matter. They are boundaries created by the structure of reality itself, and beyond them, physics becomes speculative. We can describe what happens up to those edges with confidence. Beyond them, our equations still exist, but their meaning becomes unclear. We do not know whether those boundaries hide deeper layers or mark the end of meaningful description. Another subtle mystery involves how much of reality is determined versus open. The universe follows laws, yet outcomes often depend on probability. Some events are inevitable, others are fundamentally uncertain. Whether the future is fully fixed or partially open remains unresolved. If everything is determined, then uncertainty reflects ignorance. If not, then indeterminacy is woven into reality. Both views fit existing data. We do not yet know which reflects the universe more accurately. Then there is the question of why complexity persists at all. Given enough time, systems tend toward simplicity. Energy spreads, differences fade, and yet the universe supports complex structures for billions of years. Even now, galaxies form, stars ignite, and chemistry continues. This persistence depends on delicate balances: gravity against expansion, fusion against collapse, radiation against cooling. Slight changes would erase complexity quickly. Why the universe allows this extended window of richness is still unclear. Some see it as coincidence, others see it as necessity. Both interpretations remain speculative. Another unresolved issue is how information is encoded in reality. Information appears to be fundamental. Physical processes preserve it. Black holes challenge it. Quantum systems distribute it non-locally. The universe seems to care about information, but we do not know why. Is information a property of matter, of space-time, of something deeper? No single answer has emerged. Even time itself may be informational rather than fundamental, a measure of change rather than a background flow. If so, then when change stops, time may lose meaning entirely. This possibility reshapes how we think about beginnings and endings. There may be no before the universe and no after its end, only transitions between states of description. Another mystery lies in the silence of the cosmos. The universe is vast and old. Stars and planets are abundant. Chemistry is widespread. And yet no clear signs of other civilizations have been detected. This absence is not explained. Possible answers range from rarity to fragility to vast distances to limits of detection. But no explanation has been confirmed. The silence remains, and it raises uncomfortable questions about longevity, visibility, and the conditions required for intelligence to persist. Yet even this mystery may reflect perspective rather than reality. The universe does not owe us companionship. It does not prioritize communication. It does not optimize for being noticed. It simply exists. Another subtle unknown concerns whether reality is fundamentally simple or irreducibly complex. Some physicists hope for a small set of elegant principles from which everything follows. Others suspect reality may resist compression, that no short description captures it fully. Both possibilities remain open. If reality is simple at its core, we have not yet found that simplicity. If it is complex all the way down, then explanation may always remain partial. Either way, the universe does not promise closure. As these uncertainties deepen, something important becomes clear. The universe is not structured around human understanding. It does not present itself in digestible pieces. It does not reveal secrets on a schedule. It does not resolve contradictions for comfort. Understanding arrives slowly, unevenly, and sometimes not at all. And yet, there is something deeply human and deeply universal about continuing to ask. Curiosity is not efficient. It is not guaranteed to succeed. It often leads to more questions than answers. But it persists anyway. This persistence mirrors the universe itself. The universe does not rush toward an endpoint. It unfolds gradually, allowing complexity to emerge, fade, and re-emerge in different forms. It does not repeat itself exactly. It does not hurry. In that sense, inquiry is not separate from reality. It is one of its expressions, a temporary pattern arising within the larger process. And like all patterns, it will not last forever. But while it exists, it allows the universe to be reflected upon from within, not fully, not perfectly, but meaningfully. Perhaps the most honest way to approach the unknown is not to treat it as a challenge to be conquered, but as a landscape to be explored slowly, to accept that some regions will remain unmapped, that some paths lead nowhere, that some questions dissolve rather than resolve, and that this is not failure. It is fidelity to reality as it is. The universe remains vast, layered, and unfinished. Understanding remains partial, provisional, and evolving. Between them lies a quiet space, not of answers, but of attention. And in that space, mystery does not threaten meaning, it deepens it. As the questions continue to unfold, another realization quietly takes shape. Much of what we call reality may be shaped less by what exists, and more by how existence is constrained. The universe is not only defined by objects, forces, and events, but by limits. Boundaries that determine what can happen, what can be known, and what can never occur at all. Some of these limits feel intuitive, others challenge the deepest assumptions we make about existence. One such limit is the speed at which information can travel. Nothing can move faster than light, not because light is special, but because space-time itself enforces this restriction. Cause and effect are bound to this limit. Events cannot influence one another beyond it. Yet this raises a mystery. Why does the universe have a speed limit at all? Physics describes how it works, but not why such a limit exists in the first place. Reality could have allowed instantaneous influence, it did not. This single constraint shapes everything, from the size of stars to the structure of galaxies to the impossibility of observing the universe all at once. Another profound boundary lies in measurement itself. Quantum mechanics tells us that certain properties cannot be known simultaneously with arbitrary precision. Position and momentum, energy and time. The more precisely one is known, the less certain the other becomes. This is not a limitation of instruments, it is a limitation built into reality. Why the universe enforces uncertainty at fundamental scales remains unknown. Whether this uncertainty reflects randomness or hidden structure is still debated. Either way, reality refuses to be fully pinned down. Then there is the boundary between existence and non-existence. Particles can appear briefly from empty space, borrowing energy from quantum fields before vanishing again. These fluctuations are measurable and real. They influence cosmic expansion and atomic behavior. This blurs the distinction between something and nothing. If nothing can produce measurable effects, then what does nothing truly mean? Is empty space truly empty, or is it simply a quiet form of something deeper? No clear answer exists. Another unresolved mystery involves the arrow of time. Time moves in one direction. Causes precede effects. Memories point backward, not forward. Entropy increases. This directionality is universal, yet the laws of physics mostly work equally well forward and backward. Why time has a preferred direction remains unexplained. Some theories trace it back to initial conditions. Others suggest deeper asymmetries. None fully account for why time feels so different from space. Even more unsettling is the possibility that time itself may not be fundamental. Some models suggest time emerges from change, correlation, or information flow. If true, then time is not a backdrop in which the universe exists. It is a property that arises only under certain conditions. If those conditions disappear, time may disappear with them. This possibility reshapes how we think about beginnings and endings. There may be no moment before the universe and no state after it ends. Only transitions between regimes where time makes sense and regimes where it does not. Another deep uncertainty lies in the nature of physical laws. We treat laws of physics as fixed, universal, and timeless. But we do not know whether they truly are. They may be stable across observable history, or they may evolve too slowly for us to notice. If laws can change, even slightly, then the universe is not governed by eternal rules, but by long-lasting patterns. And that possibility opens unsettling questions about predictability. If laws evolve, then certainty itself becomes temporary. Another unresolved issue concerns why the universe exists at all. Science explains how systems behave once they exist. It traces causes within the universe, but the existence of the universe itself remains unexplained. Why is there something rather than nothing? Why do laws exist rather than chaos? Why does reality follow patterns at all? These questions are not unscientific. They are simply unanswered. Some argue they are meaningless. Others see them as the deepest mysteries of all. Either way, they remain open. There is also the question of whether the universe is unique. Our observations are limited to one cosmos. We do not know whether it is the only one of many, or part of a larger structure beyond observation. Multiverse ideas attempt to address this, but remain speculative. Without access to other universes, if they exist, the question may never be resolved. And yet, the possibility itself influences how we interpret fine-tuning, probability, and explanation. Another quiet mystery is why mathematics describes reality so well. Equations written by human minds, often developed without physical motivation, later turn out to describe nature with uncanny accuracy. This correspondence between abstract symbols and physical behavior is not explained by physics itself. Is mathematics discovered or invented? Is the universe mathematical at its core? Or is mathematics simply a language that happens to fit? No consensus exists. Then there is the question of whether reality is continuous or discrete. Space appears smooth at large scales. Quantum theories suggest discreteness at small scales. Whether space-time is ultimately continuous or composed of indivisible units remains unresolved. This matters because continuity allows infinite divisibility, while discreteness imposes fundamental limits. Which description reflects reality remains unknown. As these mysteries accumulate, the universe begins to feel less like a fixed object and more like a layered structure of constraints, permissions, and prohibitions. Reality is not defined only by what happens, but by what cannot happen. Some events are forbidden, some measurements are limited, some questions have no operational meaning. These boundaries are not obstacles placed in our way. They are features of the universe itself, and within those boundaries complexity emerges, briefly, locally, and beautifully. It is within these constraints that stars burn steadily rather than explosively, that atoms form stable structures, that chemistry persists, that life arises. Constraints do not eliminate possibility, they shape it. This perspective transforms mystery from absence into structure. What we do not know is not empty space waiting to be filled. It is terrain shaped by deep rules we are only beginning to sense. And perhaps this is the most important shift of all. Mystery is not the opposite of understanding. It is the outline of understanding. Each unknown marks where explanation thins, where assumptions weaken, where deeper layers begin. The unknown is not failure. It is orientation. It tells us where to look next, and sometimes where not to look. The universe does not invite us to master it. It invites us to engage with it, carefully, patiently, without expectation of final answers. In doing so, we participate in a process older than stars and quieter than space itself. The gradual, tentative unfolding of comprehension within a reality that does not promise completion. The universe remains vast, constrained, structured, and unresolved. And within it, curiosity continues, not because it will finish the story, but because the story is still being written. as everything gently comes together, the final realization is not about a single mystery or even a collection of them, but about what it means to exist inside a universe that will never fully explain itself. At this point, the unanswered questions stop feeling like loose ends and start feeling like the natural shape of reality. The universe does not behave like a book with a final chapter. It behaves like a horizon, always present, always receding, always just beyond complete reach. This does not mean understanding is futile. It means understanding is contextual. Every explanation works within limits. Newton's laws describe everyday motion perfectly, yet fail near light speed. Relativity explains gravity and time, yet breaks down at quantum scales. Quantum mechanics predicts outcomes with astonishing accuracy, yet offers no clear picture of what reality is between measurements. Each framework is true, but not complete. And this layered truth may be the deepest feature of the universe itself. Reality appears to be built in such a way that no single perspective captures everything. Every viewpoint reveals something while hiding something else. Every scale brings clarity and confusion in equal measure. At human scales, objects feel solid, time feels continuous, and cause and effect feel reliable. At cosmic scales, space stretches, time bends, and simultaneity dissolves. At quantum scales, certainty vanishes, probability dominates, and observation itself becomes part of the process. None of these descriptions are illusions. They are all valid within their domains. The mystery lies in how these domains coexist without collapsing into contradiction. This coexistence suggests that reality may not be reducible to a single story. It may be fundamentally plural, composed of overlapping descriptions that never merge into one final explanation. And that idea quietly challenges one of our oldest assumptions, that knowledge must eventually converge. Perhaps it does not. Perhaps knowledge expands outward instead, growing richer, more nuanced, and more conditional, without ever reaching closure. This reframes ignorance not as a temporary gap, but as a permanent companion to understanding. There will always be questions that lie just beyond reach, not because we lack intelligence or tools, but because the universe itself has depth. Depth implies that no matter how far you go, there is always more beneath. Another subtle truth becomes visible here. Certainty is not required for meaning. Stars do not need to know why they shine in order to shine. Galaxies do not need to understand expansion in order to expand. And minds do not need final answers in order to wonder. Meaning arises not from completion, but from engagement, from noticing patterns, from asking questions, from recognizing limits without retreating from curiosity. In this sense, mystery is not a barrier to significance. It is its source. A fully explained universe would be static, predictable, closed. A partially unexplained universe remains alive to exploration. Even the idea of truth becomes gentler here. Truth is no longer a final destination. It becomes a process of refinement. Each generation clarifies some questions, reframes others, and uncovers entirely new mysteries that could not even be imagined before. The universe does not punish this incompleteness. It accommodates it. And within that accommodation, something remarkable happens. Humility and wonder coexist. We can acknowledge how little we know without diminishing what we do know. We can accept limits without surrendering curiosity. We can live inside uncertainty without fear. The universe is not withholding answers out of cruelty or indifference. It is simply structured in a way that does not prioritize explanation. Existence comes first. Understanding follows, partially, locally, and temporarily. This realization changes how we listen to the unknown. Instead of demanding resolution, we begin to notice texture. Instead of seeking closure, we become attentive to nuance. Instead of asking when mystery will end, we ask how it shapes perspective. And in doing so, mystery becomes less threatening and more grounding. It reminds us that we are participants, not overseers. We observe the universe from inside it, with tools built from its matter, governed by its laws, limited by its horizons. There is no external vantage point from which everything becomes clear, and that is not a flaw, it is honesty. Perhaps the most profound unanswered question is not about dark matter, time, or the origin of space, but about why beings capable of reflection exist at all. Why does the universe produce complexity that can question its own existence? Why does matter organize itself into systems that can contemplate the whole? This question has no clear answer, but its existence alone tells us something important. The universe allows moments of awareness, however brief, within an otherwise indifferent expanse. Those moments do not change the universe, but they change how the universe is experienced. And experience, while not fundamental, is real. As this journey slows to a close, it becomes clear that unanswered questions are not the universe's unfinished business. They are its character. They shape how reality unfolds, how understanding evolves, and how meaning emerges within limitation. The universe does not rush toward clarity. It does not promise revelation. It does not reward certainty. It simply continues. And within that continuation, curiosity persists, quietly, patiently, without expectation of final answers. Perhaps that is enough, to exist in a universe that does not explain itself, to ask questions that may never be answered, to find calm not in certainty, but in scale. The unknown does not diminish reality, it expands it. And as long as there are questions left unanswered, the universe remains open, not as a puzzle to be solved, but as a vast unfolding process that invites attention, reflection, and awe. Not because it demands understanding, but because it allows it, slowly, partially, and beautifully,